Welcome to Unit 2, Topic 3. Today we're going to be discussing the size of cells. All right, so cellular metabolism depends upon cell size. And what this means is that cell size is going to dictate what the cell can actually get done. So cells, for example, need to all do a few things, and we can see that in the image below. So they all need to get rid of cellular waste, they all need to dissipate thermal energy, but then they all need to bring in nutrients and other resources or chemical materials that they need to function. And at a certain size, it just begins to become too difficult for a cell to regulate what goes in and what goes out of the plasma membrane. And so when cells get overly large, they start losing functionality and they're less efficient. And that's where this concept of surface area to volume and their ratio comes into play. So the cell of a size will dictate the function, and cells need to have a high surface area to volume ratio to optimize the exchange of material through the plasma membrane. And so what we're going to go through today are the formulas for spherical and also cuboidal cells and how we can calculate their surface area and their volume and then determine whether or not they have a high or low surface area to volume ratio in comparison to other cells. So let's go through our formulas. Remember, you don't need to memorize these formulas because the AP exam will give them to you. But let's go ahead and just look at them, and please write them down in your notes so that you have them as we work through the problems. So for cuboidal cells, the surface area, you can do, sometimes they'll give you problems where there's just one cube to represent one cuboidal cell. But then sometimes there's lots of cubes, and I'll show you an example where that's the case. So if you see lots of cubes, you're going to use that first formula. So it's surface area is height times width times number of sides times number of boxes. Or if there's just one box or cube, then it's just surface area is 6 times the side squared. Volume is height times width times length times number of boxes. Again, if there's multiple, if there's one, it's just the side cubed. If, like I said, just one box. And then the ratio is just surface area divided by volume. Then for spherical cells, we can see the formula is there. Again, the ratio is just surface area divided by volume. And again, these formulas are given to you, but please write these down so that you have them and you can see them as we go through the problems. But let's go ahead and go through some practice problems now. First, we're going to look at cuboidal cells, and the second one is an example where we see multiple boxes. So we can see cube number 1, cuboidal cell number 1, the units are arbitrary for both, but for the first one, it has a side of 3. And then for the second one, each box has a side of 1. And I want you to calculate or answer and use your calculations to answer which would have the best exchange of material through the plasma membrane. So go ahead, take a minute, calculate the surface area to volume ratio for cell 1 and cell 2, and then determine which would have the best exchange of material through the plasma membrane. All right, so here is the work. So go ahead, check your work against mine. Cube 1 or cell 1 had a surface area to volume ratio of 2. And then cell 2, which had multiple little compartments, it was compartmentalized, had a surface area to volume ratio of 6. And we said that cells need a high surface area to volume ratio to optimally exchange material with the outside or through the plasma membrane. So which one is higher? 2 or 6? Well, obviously 6. So cell 2 or option 2 is going to have the higher surface area to volume ratio. Therefore, it would be best at exchanging material through the plasma membrane. All right, let's look at another one. This one I'm actually just going to walk through with you so you can see how the formula works. For spherical cells, it's pretty easy. So unless you're asked to show your work, you can determine very quickly which cell would be best at exchanging material through the plasma membrane. So here are our formulas. And if you sort of set this up just using the formulas itself without plugging any specific numbers for radius, you get this, 3 over r. 3 over the radius. Why does this matter? Well, this helps us to see that as the radius increases, then the ratio of surface area to volume will decrease. What does that mean? Well, the larger the spherical cell, the less optimized it is at exchanging material through the plasma membrane, right? So the smallest cell is always going to be best at exchanging material. So that'll help you very quickly identify on the AP exam the best cell if you're given all spherical cells. But let's go ahead and now try it with some numbers. So here's cell 1 and cell 2, and there's the radius for each. And I want you to answer this question again, which would be best at exchanging material through the plasma membrane. Go ahead, do your calculations, and we'll come back together. All right, so here's the work for cells 1 and 2. For cell 1, I got a surface area to volume ratio of 0.6, and then for cell 2, I got 0.37. So which one has a higher ratio? Well, cell number 1, and it is the smaller cell. So cell number 1 would be the best at exchanging material through the plasma membrane. All right, go ahead, work on practice problems 1 through 11 in your packet. Okay, so what does this mean for a cell? Why did we calculate all of this? Well, we went through this to show that cells tend to be very small because small cells have a high surface area to volume ratio. And cells that have this high surface area to volume ratio have optimized exchange of materials between or through the plasma membrane. Larger cells have a lower surface area to volume ratio, therefore they lose efficiency exchanging materials. What does this mean if they lose efficiency? Well, the cellular demand for resources increases, right? Because they're not able to efficiently transport material in and export material out, right? So their demand for resources is going to start to increase. And then also the rate of heat exchange is going to decrease in large cells. And so this is why cells tend to be small. All right, that's it for topic 3.